much. Good morning, everybody. Thanks for your time and joining us here. We're going to talk about a highly entertaining topic of cybersecurity. When we mix it with blockchain, these are some of the really interesting challenges. So I'll start with just a sort of slightly provocative statement. It's important to understand with a blockchain that the data that we store on the chain, while it's immutable, the ledger never changes, right? You know, once data is recorded, it stays the same for all time and is protected by math. It's important to understand that the data that's written on the chain, we cannot prove that it was intended. So basically, pretty much, we have no idea what they wrote on the chain. And what we mean by that is we don't have any evidence to say how your private key was protected. If all I have is the chain, I have no idea whether you did the transaction or somebody who stole or borrowed your private key did the transaction. I just know that a key did the transaction. Well, so that's an interesting challenge if we're going to try and put land records on the internet, and then we're going to have a court case and we're going to try and prove that the land records we put on the internet were the ones we intended. Well, what we're going to need to do is we're going to need to go back into the old IT systems, and we're going to dig out those Windows log files, and we're going to see whether or not you had control of your PC on that day, and then we'll check with the Oracle database to see whether or not your network security situation has been good for the last, well, we probably need to know since the beginning of the time you actually opened a wallet, because any time along that we could have stolen your key. So who knew that all that ancient IT stuff was the stuff that actually secures the blockchain? That probably wouldn't go over really well if we talked about that concept and said what we need to do is start archiving all the log files, because that's how we prove that the blockchain is real. So it's a really interesting challenge, and we've tried to come down the path of bringing a long history of, I come out of the trusted computing space. Spent 15 years or 20 years of my life in building hardware security and components that go into PCs and phones and other devices to help assure that the things that a device does are actually the things you intend to have happen, because most of the time your computer's probably lying to you. So this idea that we need provable events is great, but we also need to prove the data associated with the event. So what Rivets has done is we have focused on how do we take these technologies and pursue a path of a known device in a known condition with a known set of users executing a transaction. And while it's relatively simple to say, it's not so easy to do. It's not just authentication. It's not just logging you in. Blockchain is not an authentication technology. We think about authentication. There is no authentication in blockchain. It's important to understand that. There's only encrypted messages. So what you do is you create an instruction. You sign that instruction and you send it to the network, and the network checks to see whether or not it was signed by a key that it understands, and if so, it processes it. And so this is about the process of creating a high assurance instruction. By the way, we've been doing this for a long time. One would argue in the sort of classic movie model of the nuclear football, that creates secure instructions. What does it do? A guy carries around a football. We keep it safe by handcuffing it to a dude with a gun. That turns out to be a really good way to protect your hardware wallet. Like if you have a guy who's well-trained with a gun, you handcuff your wallet to him, and anybody who touches him, he shoots them. And you get a couple other guys to follow that guy around just in case he misses, right? That actually turns out to be quite good. And so if you have a lot of money getting the nuclear football team to follow you around with your wallet, that would be excellent. And what does that device do? It creates an assigned instruction, sort of the, let's not worry about the actual real details. Let's just stick to the Hollywood details. It's like the Hunt for Red October. They send the instruction, and then the message gets corrupted halfway through. And so they got this instruction. They can read the message, but they can't check the keys. And so then there's this big debate whether we should process the instruction or not process the instruction because we don't have an authenticated signature. We shouldn't process the instruction unless the signatures match. And then what you hope is that you have a trustworthy system and the guy running the silo that reads the instruction and then follows the instruction. You don't want him having a debate as to whether or not to put your Bitcoin, or maybe we should, really they're spending way too much. This is really not a good idea. It's just before Christmas. You shouldn't be spending all your money on something. We don't want the silo having a debate with us about whether we should spend our money or not. We want the instruction to be followed. And so how do we create that known device in a known condition with a known set of capabilities to produce a high assurance instruction? So let's talk a little bit about the existing security situation. Today, this is kind of the model. We build a fence, and then we put the crown jewels inside the fence. This is classic enterprise security. This is what everybody does. And we've been doing this for like 25 years. Network security watches all the transactions going in and out to make sure that the right machine, you didn't have any malware, this is all firewalls, they block the traffic if you're coming from Russia because we should only be getting traffic from our guys in downtown Austin because that's where the office is, so what's this Russia traffic coming from? Well, so the challenge is we moved all the crown jewels into the cloud. So this is a really interesting problem because where's the stuff? Well, we've been trying to do recently is put a fence around the cloud, which turns out to be really hard because the users left the building, so they're not inside the building. What basically we did was we moved the crown jewels to the cloud and assumed that the employees are still inside the fence, so we reversed the fence and made sure that the traffic going to the cloud came through our firewalls. The users have left the building. The users are at Starbucks. The data's in the cloud. There is no fence anymore. That's part of the real problem we have with cybersecurity today. So then we had this brilliant idea, let's build a blockchain. The blockchain is fantastic because that's what we've done. We've put the crown jewels everywhere, right? So everybody running a node is running the ability to execute an instruction. So where do you build the fence? Well, IBM thinks it looks like this, right? That's a private ledger. You might actually draw all the crown jewels inside one giant fence, but this is, if a bunch of companies get together and decide to have a private ledger, then they can put their own fences around each other and we can watch the traffic. And this is how we make sure that when I have a key and it's Goldman Sachs and Bank of America and pick 10 other banks and they're sharing a chain, they can make sure the instructions only come out of one of their banks. And if traffic starts coming in from either the 400-pound guy in the basement in Detroit or the North Koreans or the Russians or pick your adversary of choice, right? How do I know that the instructions that are arriving are the ones we expect? And so we've set out to try and solve this problem. I added this slide this morning because this is an observation from a conversation we were in last evening, just before we went out to the parties last night. And we were talking about censorship resistance on a public chain and how censorship resistance is like one of the core properties of blockchain. It's one of the things we absolutely have to protect. I think that's true. I think it's a very cool aspect of this conversation of we're taking control, and whether it's a nation state or the banks or others can't artificially control or eliminate the transactions, right? We can all of a sudden transact money anywhere in the world. We can put blockchains in space. It's going to be fantastic. There's a problem. The public blockchain is also completely resistant to network security. And so that's actually a problem because we've invested as a community $1 trillion in network security over the last 20 years. It's all we know how to do. So all of our banking, all of our SCADA networks, all of our real estate, all of our infrastructure around identity, everything we do today is protected by network security, a firewall. Excuse me, I forgot to turn off my phone. We just said, yeah, thanks. So that's an interesting problem. It's almost like a rule. You can't apply network security to blockchain. So how are we going to secure this stuff? We need a completely new paradigm for security, for blockchain, to secure the instructions. So I come from a history of trusted execution. We have invested in as an industry and built standards around, and there are conferences as large or larger than this that all we do is sit around and talk about trusted execution environments and trusted platform modules and how we hold keys in hardware and what it means to make those systems tamper resistant and all the parts that are along that. Actually, there was just a big conference last week, ARM TechCon, which is all about, a big chunk of it is about the cybersecurity within the ARM processor. And what trusted execution is a small, highly assured, measured environment. We use the word trust, but it's a little bit dangerous to use the word trust in this context. The trust model is such that It really is about measuring the system, not sort of a blind trust of the system. What we're asserting is that the systems are the same as they were yesterday. So if I have a system and I've characterized it and I've validated that I've set it up in a safe manner and I take a snapshot of it, I basically get a signature that says this device is in this specific condition. And so now when I come back tomorrow or a month from now or a year from now, I can ask again, is the system in the same condition that it was before? And if it is, then I know that it hasn't changed, that somebody hasn't altered that infrastructure. It is whatever I measured. Now, if I don't measure very much stuff, I don't have very much security. If I spend a lot of time measuring all the gory details, I can make many more assertions about the platform. It's based on industry standards, and what makes it safe, and the reason why people use the word hardware when they talk about this is because software can't move the copper wires. Deep down inside in the chip somewhere, we've actually wired up the chip with some logic to do things like a core root of trust measurement, where we can take the first steps in building a chain of trust from a set of keys, where that's actually hardwired into the silicon. And so the theory is you can't move the wires. At least you can't move the wires with software. We'll sort of step away from let's take the chip apart, get some lasers out, and the hacking of the hardware stuff is just really great. And it's quite amazing what's possible to both extract out of chips that are claiming they won't let keys go, side channel attacks and things like that. Like you can extract all the keys out of an iPhone from about a meter away for everything. There's not enough sufficient hardware security in the iPhone to do that. You can just rip them out of the phone. And these are some of the tools that work to enhance those side channel attacks, that protect the security. They're not perfect. There are chips that are better than others. Mostly we're dealing with consumer grade security level. You could think of these as like $100,000 vaults. They're probably not billion-dollar vaults. Billion-dollar vaults are like what we're putting in the F-35 in order to assure that the software in our fighter planes can't be hacked remotely. Those are much more sophisticated, much more characterized than what we're getting for 50 cents in a phone. And fundamentally, we should have only known developers and only known code. There should be no anonymous code running in a trusted execution environment. That's the goal. Because if we have anonymous code, then who wrote the code? Well, we don't know. It's anonymous. Well, what happens when we discover that they made an error or an intentional error that made a hole in the code? Who's liable? We actually want to know liability in this case. We want to know that if she built the code and she put a hole in it and therefore 1 million people lost their Bitcoins, we know who to call, right? So it's important. Identity is a very important piece of this puzzle. People won't write perfect software. They'll make mistakes. We want to know whether it was a mistake or intentional. So the way this works is there's this very small programming space that has its own operating system inside the chipset of your phone. So in the ARM processor, in everybody's phone, there's a technology called ARM Trustzone, which runs this isolated execution environment. And about 4 or 5 years ago, a joint venture was done between ARM and Gemalto, the big SIM chip company, that made it possible for us to program this capability over the air. So in a Samsung phone or an LG phone, I can reach over the air and I can put one of these little trusted apps inside your phone that runs independent of the Android operating system and will allow me to hide and process secrets inside the silicon of your chips, which is really cool. So we, on the trusted world side, build a little app that performs those functions. And then we have normal app infrastructure that runs on your phone. So you download an app, it automatically provisions one of these little kernels that runs inside, or these little apps that runs inside the security kernel of the phone. And now we have capabilities, and we can do things like two-factor authentication and encrypted messaging and blockchain transactions. So one of the other interesting aspects of using this security chip within the phone, or the security capability, is it has some other features. So some of the phones, not all of them yet, support secure display. And what secure display is the ability for the phone to put a message on the screen that's independent of the operating system. So I can ask you to confirm a message on the screen that I know what you see is what's going to get signed. So I can assure that the consumer who's just looking at their phone, they just have another screen comes up and they say, yep, send 5 Bitcoins off to Michelle and, and that's a great transaction. You know that that's actually what's going to happen, as opposed to what your phone says and what it does are two completely independent things. And it's important to understand that. Your PC can lie to you. And that's how we lose money in e-commerce every single day. And it's easy to do that in Bitcoin, right? How many people have gone to the wrong website in an ICO where some scammer is trying to put up a different address and trying to get you to, hey, this site has 50% off today only. And that's usually a good sign. It's probably not legitimate, but you'd be amazed the number of people who actually put money into those addresses. It's quite phenomenal. So I thought I'd put this up there. It took me a long time to learn this. I was working in the space of e-commerce for almost a decade before I learned this. This was a result of a fantastic meeting where I had a guy who worked for me there's this standard in payments called EMV, EuroPay, MasterCard, and Visa. And the guy who was the MasterCard rep who wrote the spec in the 80s worked for me. And he's like, you don't know what you're talking about. We should have a meeting. So he brought along his friend who worked for EuroPay so I had E and M of EMV in my office, spent the entire afternoon telling me that I had no knowledge or understanding of what a proper EMV transaction was. So this is the first piece. When you go to Walmart and you put your smart card into the little Walmart machine, there's a screen on that machine, and that screen is a trusted measured display. What's printed on the cash register means nothing. What's printed on that little screen that says you just spent $79.45 at Walmart is the transaction that's going to get sent to the network. Then there's some form of trusted input. So trusted input is that PIN number you're supposed to type in. Now, most of us are Americans. We live in the US of A. We're too stupid to remember PIN numbers. So when they launch chip cards, we have chip and signature. By the way, nobody checks the signature. Shh. We're too stupid in America to remember the PIN number. The rest of Europe, the rest of the world, they have like a 4 or 6 digit PIN, which actually makes the transaction safe. So right now, if you lend your chip card to somebody, they can use all the money on your account because they can sign any name they want into the cash register. Nobody checks your driver's license. It's really quite phenomenal. So trusted input is important. We just don't use it here in the US because we don't really care about security very much. Then the third piece is trusted execution. This is on that little chip on your card. It holds the private key that signs the instruction, just like a Bitcoin transaction. By the way, this is what a Trezor wallet does, or a Ledger wallet, right? Secure display, trusted input of some kind, so you have some type of PIN number to access, and then proper protection of the keys. But there's a fourth piece. Nobody ever talks about the fourth piece, which is some type of attestation or verification that the other 3 pieces are working correctly. You could think of this as PCI compliance. That's what the industry calls it in the payment industry. In trusted computing, it's called attestation. And so what we did at Rivets is we did a transaction a year ago now, actually, where we demonstrated a Bitcoin transaction. If anybody wants to come see it, I have a little video of it. I'm happy to show it at the booth. It's kind of a little esoteric for the whole audience. But what we did was, when you create a wallet, we took a reference health and integrity of those components in your phone. We record that as part of the wallet creation. Then when a spend transaction goes through, we take a real-time health integrity measurement of the device. And we only let the spend go through if the device you're using is in the reference condition that you expected when you set up the wallet. By the way, we record that signature on the chain. So now if I look at the chain, I can see, oh, yep, I gave 5 Bitcoins to Michelle, but there's also another signature in that transaction that says, and I did it with a device in this condition. So now what I have is a provable cybersecurity control on a peer-to-peer transaction, and you're meeting the fundamental consumer protection essence of what New York BitLicense was looking for, which is tell me that you've provided some customer protections. How do I know whether the device you're using was the device you intended to use to perform this transaction? Was it in a condition you expected? And if it is, then I've satisfied you as the owner of the platform that your cybersecurity controls, whatever you chose to put in place, are in place for that transaction. So we're verifying what are the basic capabilities. And this is pretty simple measurements today. We're not as sophisticated as we'd really like. Different platforms have different capabilities. We can measure the BIOS integrity of your machine, make sure it's at least not running a Russian BIOS before you boot it in the morning. Nobody checks the BIOS of their machines anymore. You have to, otherwise you have no idea who's running your computer. We register those reference measurements and then we verify them at a transactional level. So we're continuously monitoring as you do transactions on a completely decentralized basis with no central control that your device is in the condition you expect it to be in. So this summer, we launched an ICO, and we were very pleased to successfully complete that ICO. We raised about $18 million in Ethereum. And it was all about creating a token that will fundamentally put this to work for any service or any application. So the underlying purpose of the token is not only there to operate this attestation layer in the network, but also to assure that, that there's some stored value in the machine for external controls. One of the things that we did was really cute is we used the trust agent in the device to not only perform the transaction, but it can, before it performs the transaction, ask any external service whether or not that device is in the right condition. So there are different kinds of services. I could ask, is this phone in Nevada because I want to spend gambling money? I'm only allowed to spend gambling money if I'm inside the borders of Nevada. I could ask the carrier, hey, am I in Nevada? Or I could ask Citibank, could I please have a token that says I've completed an KYC AML for a $1 million transaction, a know your customer and anti-money laundering for a $1 million transaction. Give me a token that says I've completed that, and then let me stuff that token into the transaction going forward because this wallet requires a Citibank KYC AML to advance. Oh, so now we just did a $1 million transaction where the exchange has no idea who I am, but they know I passed KYC AML. Privacy with KYC, that would be slick. Because there are lots of exchanges where people don't want to watch the transactions going on. I might be buying a company, I might be buying a boat, I might be whatever, and I don't actually want people to know who's performing that transaction. But that doesn't mean we shouldn't be in compliance with whatever the rules are to support that. So the chain just has a big random number on it. So we have great privacy. It's tokenization of KYC. And so this provides really an on-demand delivery of cybersecurity controls. How do we assure that the things the owner wants to have checked are checked? Like I could put a beacon in this room and say you can only ever spend the Bitcoin in this wallet from this room, period. That's cool. You can steal all my keys. You cannot execute a transaction unless you're standing in this room because you'd have to completely circumvent all the rest of that security. Has a whole new meaning to like that safe room in your house. We're in Texas, so yeah, you need a long driveway, you need a big dog, you need an adequate armament, right? And a safe room. Now we put a beacon in that, and now you call that your Bitcoin wallet. Now that has a whole new concept of construction. So this is sort of a picture of that piece where we use the tokens to pay for those additional cybersecurity controls. I don't care what they are. We did a deal with Telefonica where we're supporting their cyber threat center with a token. So before I perform a two-factor authentication to log you into your Gmail account, I can ask the cyber threat center whether or not your Gmail is showing up on the dark web. Because I'm about to type in the second factor, somebody already stole your Gmail account. All they now need is to steal that second factor token to steal all your email. So maybe I shouldn't let you log in. There's so many different possibilities that are there. We expect a whole range of service providers, not just us, building those cybersecurity services so that our tokens get put to work. Because tokens are a really cool thing. We are trying really hard to be a poster child for a utility token. They're having the regulatory panel next door. We could talk a lot about the regulation that's necessary in this context. As part of building a utility token for cybersecurity controls, do I want to have to push a button as a human every time a cybersecurity control is checked? Like, check and see if I'm in the room. Check and see if I'm in the state. Check and see if, my threat center says I'm in a good condition. No, I want that to happen automatically. One of the big problems with utility tokens is automation. If I want automatic money, like a good bot shows up and says, hey, can I have some money? You don't want your machine to just automatically hand out its allowance to anybody who wanders by. And actually, there's a really good example of this in fraud that's in the network today, which is click fraud in advertising, right? It's kind of automatic money, and it's like, what, 20% or 30% of all advertising transactions are click fraud? It's like an enormous number. So if we put this on millions of devices, all of a sudden, because there's an exchange that can convert a token and like run it through the Bitcoin washing machine, you can go buy Ferraris with them, you know, we need a better mechanism to protect those tokens within a device as the more they become utility tokens. Because we're going to want our machines to work for us, not ask us to sit there and be the button pusher that's like, you know, it's like, imagine a washing machine in your house where every time it changed the steps in the cycle, it required you to go push another button. Like, you could have one, it would go like beep, it would call you on the phone, it'd be a whole internet of things. So you can run into the laundry room, push the button for the next stage. Like, this would be a really annoying machine, right? We don't want that. We want the machine to know, like, put it on this delicate wash cycle, and it does the whole thing by itself. It's fantastic. So Rivets is all about creating that fence within the device using the trusted execution environment, which you can almost think of like a smart contract. It's not, but it's still an assured execution process that a smart contract is, using different technologies, that says these tokens can only be spent for the following things at a velocity level, at a value level. So you're allowed to spend $1 buying, you know, civic services for the week. And so you can put some civic money on your money and know that that token isn't going to just get ripped by somebody else. And so we think machines with money is an interesting piece. And it ultimately, I think, drives the value of our token in the market. Because what we want is, you know, a few 100 million machines that each need a $5 allowance on it. Somebody's going to have to go put that store of value in all of those machines. And that's the purpose of the Rivet token, is to not only operate, but provide the economic model necessary to operate those cybersecurity controls. And so it's a new business model for security. This is an example of the new user model for controls and for software. We're moving to a subscriber-based business. We're moving away from buying a box piece of software that you pay a seat license for 5 years on with maintenance to more of an on-demand consumption-based model. So if you don't use it very much, you don't pay very much. You use it a lot, you pay more. And that's fine. If you use a tool a ton, you're happy to pay for the tool. But you want to like play with a whole bunch of different tools, and then you decide you like this one and you abandon that one. Like, I'm still paying my stupid Slack bill. We don't use it anymore because it got so badly hacked in our ICO that we're just like, nobody even wants to touch the thing. It still charges my credit card every month. It's like, can I reduce it down to like one employee using Slack just to preserve the data? It's amazing. And yet, so we want much more of a consumption-based model. These tokens are that tool. This is the new economic model for the consumption of software. It's not a security. It's not a commodity. I think it's probably covered by the FTC. If we like Snapchat said, hey, the messages go away after 30 seconds and all our kids are running around taking pictures of things that go away in 30 seconds and they don't really go away in 30 seconds, you should get fined by the FTC for lying to everybody that your messages went away. And they did, and they have a 10-year order against them, I think, on you're not allowed to say the messages go away unless you actually make it work. So I brought this along. It's a very short demonstration. It was something we just did for Department of Homeland Security as an example of how strong authentication could be done within an app.
Here we'll be showing how a hardware-based security solution to the TEE is not only more secure, but simpler and faster for the end user than traditional login methods. I'm presently using a Samsung Galaxy Note 4 for this demo, but the hardware enabling this technology is already built in and shipped across millions of devices. We have a traditional login form here, but the beauty of hardware-based security is that such forms become unnecessary. If you wanted, you could forego password-based authentication across an entire system and restrict account activity only to specific devices without having to worry about IP addresses, location, etc. To get started, we'll tap the hardware sign-in link. Now the Rivets app on the phone opens and prompts us to confirm that we are indeed signing into this website, itembot.com. We are, so we'll tap yes, and the app will take just a second to communicate with the authentication server. Done. This device has never authenticated to this website before, and the website allows for new device registrations. So, our unique hardware credentials have been verified, and we're prompted to enter a bit more information to personalize our account. We'll go ahead and do that here. Add an email, phone, and this website allows us to optionally add a password, but we'll skip that so that our account is only accessible from this device. Sweet, we're in. Believe it or not, that was the most complex part. Now let's log out, and logging in is just as simple as tapping the hardware sign-in button again. We again grant permission to share our hardware identity with the website, give it just a second to process, and now we're logged in. It's really that simple, without the risk of an unsafe password.
So we think that's the experience your future service enrollment should look like. You just enroll your device. You don't need to give it a password. If you want to give it a password so you can log in from lots of other things or log in from the cruise ship computer, that's fine. But your daily experience should just be that your device logs you in. And obviously you can push the Remember Me button. And so as you think about multi-factor authentication and experience we're all suffering through these days, like every bank is like sending you an SMS every time you do anything, right? Just understand that we have 1 billion devices that have the equivalent of a SIM chip. And our favorite form of two-factor authentication is dial the phone number and push the send button. By the way, take any of the other crazy schemes they're all suggesting out there, like dial the phone number, take a selfie, and that completes the call. Would you buy that phone? No. Like dial the number and wave your phone around the right way, and big data and analytics will decide whether your phone is in the right condition in order to complete the call. That would just be annoying, right? We dial the number and push send because it just works. And so these are the tools to move us more to a device registration model and away from a username and password and user-known credentials. And then we're only asking the user to be trained to one thing. If you lose your phone, notice. And the great thing is our mothers have been teaching us this for 10,000 years. Like if you lose your phone, you have a genetic response to like, oh my God, I lost my phone. Excuse me, I have to go because my phone is over there somewhere. He took it. I don't know where it is. And now I'm in a panic and I can't do anything useful for at least the next few hours till I've committed to the fact that I truly lost it. Or, oh my God, I left it in the red carpet club and they're going to FedEx it to me. So can I lock it until it arrives back to me? Absolutely. Or I know that I lost it, and so I can use my other devices, or I can just reach out and say, don't let anything from that phone log in. And so it becomes a very simple thing to manage. And by the way, you'll notice, like we stole all your passwords this morning. It's not a problem. You logged into the conference Wi-Fi. We've been ripping everybody's passwords since you got here. How do you know? Right? You just don't know. So I'll stop there. If there are any questions, happy to answer them.
Questions?
Hi, my name is Ken Bozak. That was awesome. I was wondering what would you do for recovery? If you were to lose your hardware and that was your only means of logging in, you never created a password, what would your process be to say, hey, this is me, I lost my phone, but that was my only way of logging in?
Yeah, so we function from a fundamental position that your collection of devices should be your identity and not your superphone. So you probably also have a tablet or a PC or a spouse with a PC or a girlfriend that you might trust. And so how do we take our collection of devices to be our primary recovery? And so that's something that you can operate quickly. Like I lost my phone, I can go to my PC, I can get a new phone, I can recover it. Then there's the situation where you lived a little bit north of Napa Valley and the fires came through and you escaped with, the 3 important possessions and you left your phone, your tablet, your PC and everything behind and there's just a smoldering pile of dust left, right? And so that happens. And so then you're going to want a more complex process to recover because I'm going to have to verify that you are you. And you're okay with that. Like if it takes you some time, if you have set up some mechanism that you're comfortable with that is that recovery process. And so you would like that kind of solution where then I can go get a new phone. Maybe I have to have, we've actually done some interesting work with voice recognition so you can use human authenticators as part of recovery. So maybe your mother, you call her on the phone, say, I'm me, by the way, you have to push yes that it's actually me, and you also have to call your grandmother, and between the two of them, they'll authenticate it's you because they know it's you on the phone, and they'll agree to consent, and they're part of the, what we like to call a chicken dance that you set up that recovers your account. And so it has to be under the owner's control. You can make it as complicated or as simple as you want. A corporation would be easy. You know, you can make it so that your corporate counsel and your board or whatever decide to recover. I think some of the stuff that EJ has been doing in like social encryption and social recovery is a great example of it. Like every one of the board members picks some piece of random information and that you combine all those together, that becomes your recovery key. Fantastic. You know, you need something that the good old boys at the board of directors can operate. So don't assume they're technically capable, right? Just like, yeah, pictures of the grandchildren, those are the ones that recover the key. You know, it can be a variety of things.
So I was wondering if you could expand a little bit upon, because you know, you mentioned that some Android devices have TPM chips that you can, you know, program. You know, obviously some Windows devices too. What about Apple devices? What about like the iPhone? What about like the new MacBook Pro with the fingerprint scanner thing?
So it's important to not think of them as the operating system. It's really actually Intel hardware and ARM hardware and AMD hardware all have trusted execution capabilities with them today. Then the question is whether a company like Apple will let you play. So Apple locks you out. They have since the beginning of time. Apple uses this stuff, right? It's how they do their Apple ID. It's how they secure their keychain. They assume that Apple's perfect and you should use their operating system, and that million lines of code has no errors in it because it's written by Apple guys who we know are perfect. And they write the best experience, and so therefore we should trust and use Apple for that process. It's turned out not to really be true. And so today on Android and on Windows, there are drivers that give us access to these capabilities. So as developers, we can have direct access into the hardware and we can do what we want with it. And so you can decide, right? Now, do you want to live in an Apple ecosystem where Apple is the dominant controller and can decide to turn on or off any of these features at any time, and you serve underneath Apple, and that's cool. Or you can suffer through the challenges of lots of different developers building software on different platforms, and you know, we might build things that are incompatible with one another, and you know, all the challenges that have been the contrast between PCs and Android and Apple devices over the last 10 years, right? And so some people like one situation, some people like the other. If we successfully show that you have a better, higher quality, more valuable customer experience on a device with strong hardware turned on, then Apple will either open the system so we can play or copy us. And actually having Apple as a competitor in this space is fantastic. We'd love them to do exactly what we do. Copy me. Implement it on every iPhone. I'm happy to satisfy the other 85% of the market because I'm quite comfortable that Apple is not going to deploy that solution running on Android. Right? So they're an interesting competitor in that way because they're not in your market. They just prevent you from being in theirs. Which, while it's interesting if you're in California, if you're in Costa Rica, guess what? The percentage of iPhones is very different. So there's a lot of the rest of the world, and it turns out when you combine Android and PC for the primary experience, you cover an incredible number of households. So there are certainly all Apple households, but there are really not very many of them. Yes?
What interface requires for Rivets to be able to go with Bitcoin wallets and so on? Are you going to need core dev to change something? Is there going to be some requirement? Are you going to be lobbying core dev to change and do it? And what? Or are you able to comply with whatever they have? Are you going to be a lobbying entity in the space to try and get it to interface with what you're doing?
I've learned not to try and boil the ocean while it's fun. And certainly provides entertainment. I think there are aspects of where it'd be great to change some of the things the core devs do. We could waste an enormous amount of, let's just say, raising $18 million in an ICO is not anywhere close to enough to combat that experience. The reality is, we design our systems in such a way that we can do things like a machine multisig. So I can take anybody's token without modification if it'll support a multisig and build the cybersecurity control side into a second key that is automatically responded by the device and brings that. So it's a little bit more complicated to set up, but I don't have to talk to the other partners as long as they implemented industry standard multisig. what we demonstrated a year ago, October, requires a change to, we used checksig from Stack as an opcode that is not currently in the Bitcoin core. There are people talking about putting it in or not, and we'll see. So we're a fan of segregated witness right now because we could certainly go build a chain that incorporated that script, and we could show that it had some value. And if obviously it had enough value that people thought it was cool, there's really no reason why it's been a well-researched opcode at this point in time. Could it get added into Bitcoin Core? Sure, happy to. But I'm not relying on it to launch my market into the marketplace. So I think we'll see an evolution. It's one of the reasons why we have to have our own token, is that neither Ethereum nor Bitcoin natively does a very good job of doing what is actually a very simple transaction, which is a compare of reference equals real time of two signatures. So a compare of two signatures, while possible in both spaces, in Ethereum is very expensive. And in Bitcoin Core, the parts are there in the ecosystem, but they're not currently in Bitcoin Core. So we'll push down that path. It's not critical to us. I think it'll be interesting to see how the embedding of cybersecurity controls becomes part of the conversation and becomes part of the logic as to how we execute. There are good things and bad things. People can say, look, I don't want to do Bitcoin transactions that have a bound signature of a device, because now I can subpoena you, look at your device, and determine this is actually your device, and therefore prove you actually did this transaction. Now, I need more information than what's on the blockchain, because I'm certainly not saying, hey, this is Steven's device in the blockchain. But if you come to Steven's house and you capture one of his devices and it has that signature, then you can see all the transactions I did with that device. And I'll have a much harder time saying, oh, no, you see, I really didn't do those transactions. Ernie stole my keys, right? Which is a great defense today, by the way, right? You like, I didn't do this. Who bought that stuff? Somebody borrowed my keys. Right? And you look at most of the cases that have been prosecuted around blockchain, they're using other data. It's the fact that you're at the right place at the right time with an IP address with, your picture and the new thing you just bought. Here's the Lamborghini on your Facebook page, and they know which address it was. That's probably pretty good evidence that you actually bought the Lamborghini. Is an interesting context. So we're trying to keep it really simple where we can go to market without changing the infrastructure. And that's true also for things like Gmail. We're supporting today two-factor authentication. I can show it to you also at the booth if you're interested, where we run a Google Authenticator in the trusted execution environment. I don't have to talk to Google. It's fantastic. My phone is more secure logging into Google than all of yours, for sure. Excellent. Do you want what I have? Yes. Yeah. So maybe he'll buy it, right? So maybe it costs a couple bucks. He goes to the App Store, he buys it, and then he's like, hey, now our phones are more secure than the rest of yours, right? And so that's cool. That's the way these markets come into being, because the top-down approach of like getting all the services to change it, we as an industry have spent about $1 billion trying to do that, and it hasn't worked yet at all. And it's not just me. Like, we spent our few $100 million. Samsung Knox has been spending at least a couple $100 million on this. The carriers of guys have been doing Mobile Connect. They've spent another $250 million trying to hook SIM chips up to Google. That hasn't worked yet either. So this is actually an interesting path to make it real and make it so that the individual can choose what they want to do and what level of protection they want to have. Yeah.
So first off, loved your presentation. And I understand this is a bit outside of your purview, but it still seems to me like, for example, when you did your secure hardware sign-in, that's still relying on the person's authentication into their phone being secure. If they don't have a strong password, or they don't have a password, or something along those lines happens, then once and like I said, I understand it's outside your purview, but it still seems to me like it's leaving a door wide open.
No, I think it's really cool. You get to decide. So do you use biometrics, PIN number, or nothing on your phone today? You don't even want to tell us, because if you use nothing, then you're going to be like, oh, should I use nothing, right? Right. So nothing is really cool because you can just dial the damn phone, right? And so you decide what value you put on the phone. Now, we could add a PIN number to that transaction optionally, so you could have a different PIN for every service. So you might have nothing to log on your phone and log into certain services, and log it into your cash account once you have $10 million. You might want to put a PIN number on that, because that might be useful just in case you leave your phone in the back of the taxi cab, right? Especially if you have like no other controls on your account. You can like wire all 10 million in one transaction with no second signature. People do this, right? And so that's okay. What's important is that today our only choices are like, I can lose control of my accounts and not be aware I lost control. If we start to bind it to the device, I'm really counting on this incredibly programmed into the human body, continuous monitoring of whether or not my valuable devices are still with me. Like, I come in your house and take your PC, you will notice. Right? It might take a week because you've been on vacation, et cetera, but you will notice. If I take your phone, you ever tried to remove a phone from a 14-year-old? It's fantastic. You can lose an arm doing that. Like, my younger child's 19, but a couple years ago, if you took her phone away and put it on the sideboard during dinner, she wouldn't eat. You could turn it upside down, put it next to her, and that was fine. But you moved it 20 feet away and put it on the sideboard in the kitchen, that was so upsetting to her sort of structurally that her communications device was no longer in her purview, that she would not eat dinner. And it was fascinating to watch, and that's what you're counting on. You're counting on that internal response to be like, oh my God, my $100 million Bitcoin wallet is 10 feet away. I wouldn't put $100 million on a phone. I'd put, this is a $10,000, $100,000 vault. Don't think of it as $1 million vault. For that, go buy a Trezor, put it in the safe in your house. Sure.
So I was just wondering, when does this become available for the everyday user?
Sure. So we have, as a company, we've done over $1 million worth of contract work with the U.S. government, delivering product to them. We actually just finished one of our deliverables in that. I just showed you a little project we delivered to DHS just last week. So we are shipping capability. We have not launched a consumer variant of this yet. We expect to by the end of the year. So very simple things will come first, and then we'll add complexity to them. We want to make sure that this is supported in the right time. We're very focused also in making sure we provide great support for our token holders. We ran an interesting ICO. We had this fantastic suggestion to put a chat bot on our webpage. Oh my God, what a brilliant idea. So I've had an opportunity to chat with, I don't know, at least a few hundred of my ICO participants. Guess what? Nobody knows how to operate this stuff. Nobody really actually knows. A third of our transaction, we required a data field to capture an email address. That blew up at least a third of the transactions. They had to do them again. So the only people making money is gas, right? Because people type in the wrong amount of gas, too much gas. They forget the data field, have to do it again, needs more gas. It's like the gas thing is fantastic. Nobody knows what gas is either, right? Nobody actually knows. We had to change the number a couple times, not because we needed more gas, just because it was a different number. Because people were getting too accustomed to typing in put more digits in your gas number, because if you type in 250,000, half the people type in 25,000 because they can't read. So it's fantastic. This stuff is so much more complicated than it needs to be, and everybody doing a transaction's in a panic when they push the spend button. And we've got to make that better. We've got to provide support. People are putting $1,000 into your project. They should be able to talk to somebody, right? And so I think customer support in this, I think support of the community in this is really important. We will try to do a great job of that. Will we get it wrong sometimes? Absolutely. But we are very focused on how do we support that relationship between the human and crypto. That's what Rivets ultimately does. Is how do we improve that security, support a variety of different wallets in the market or services, and make this an easier and safer experience for everybody.
One more question?
So for the consumers, what are the costs associated with this? Is it on a per device basis?
Yeah, so first off, I think the right answer is we don't know, right? We got to go try a bunch of different things and find out what really is the right balance. I think it's a range of services that are free, and that they're typically a series of upsell services that are additional cybersecurity controls that you want to put in place. So an example of a cybersecurity control is, do I have backup and recovery? Where have I put stuff? So I make a conscious decision that I want to spend a little money. Would I spend $1 to back up all the keys for all the two-factor authentications? Because I've signed up to 75 stupid online services. Each has its own two-factor authentication. Would you like that stuff backed up? Because for $1, I'll back it up for you, right? And so we think, bring them the free service, let them use it, and then provide some simple upsells that consume RVT tokens in that process, so you can get started easily and then slowly work into a process that enhances the quality and security of the platform and the usability. And ultimately, then we're delivering value on a longer-term basis, and hopefully we have a long-term relationship with that household. First their first device, then their other devices, then the rest of the family's devices. We want to help the consumer manage their collection of devices and all the services to which they subscribe.
I think that's about enough time for Stephen.
Thank you very much.
Thank you very much.